Okay, so we're looking at the second part of Module 5 here. So what we start off with is this quantity is known as the difference quotient. And if you ever take a class in calculus, if you combine the difference quotient with a limit, that's exactly what gives you the derivative. So you can think of this as really being like a slope formula between x plus h and x. And that h is kind of like a small increment. So when you take calculus, you take that limit as that increment gets really small, and it's giving you the approximation for slopes of tangent lines. So this difference quotient is f of x plus h minus f of x over h. And how to simplify because usually that's what they're asking you to do. They have the instructions here where they say simplify. So what that means is essentially we want to, the answer here is we want to eliminate the h in the denominator. So eliminating the h in the denominator often requires a number of tricks here. So the first trick I would say is either expanding or factoring. Or let's say expanding slash factoring, because sometimes they go hand in hand. So that's what's going to happen in this next problem. We're going to be expanding and then factoring, and we'll be able to factor out an h and cancel things out. A lot of times if you see something with a square root, you're going to have to rely on the trick that involves multiplying by the conjugate. And the last trick is if you have fractions involved, a lot of times what you'll want to do there is get a common denominator. So those are three tricks that arise when you're trying to simplify these types of problems. So for number 18 here, we want to simplify f of x plus h minus f of x over h given f of x equals x squared minus 9x plus 2. So really these problems are kind of lengthy algebraic manipulations. So I'm going to call this quantity the difference quotient, so I'm just going to say dq. This is equal to, well, how do we do f of x plus h? Well, we look at the formula we have right there, x squared minus 9x plus 2, and we just change the x to x plus h, and we make sure to put that in parentheses. So the f of x plus h is x plus h squared minus 9 times x plus h plus 2. And then we need to subtract the regular formula, which is just the x squared minus 9x plus 2. All of this is being divided by h. So we're not really doing anything with that h, we're just kind of working in the numerator for now. So a couple of things. One thing is to expand x plus h squared. So remember that's x plus h times x plus h, so that's something you need to FOIL out. That comes out to x squared plus 2xh plus h squared. Then we distribute the minus 9. That becomes a minus 9x and a minus 9h. Then we have a plus 2. And then we also distribute the negative sign. So we have a minus x squared, a plus 9x, and a minus 2. And then all of this is being divided by h. Okay, so once you've done that expand everything step, you get a bunch of things that cancel. So the x squared in front cancels with this minus x squared. The plus 2 cancels with the minus 2. The minus 9x cancels with the plus 9x. The second thing I wrote, minus 9x, it should say minus 9h. And then that's it. So we only have a 2xh plus h squared and minus 9h left. So now that we've canceled all those terms, notice everybody on top now has an h in common. So this is the part where you can factor out that h. So if you take out the h, you have 2x plus h minus 9 over h, and h over h is just equal to 1. So this simplifies to our 2x plus h minus 9, and that's the final answer. So a lot of things to keep track of in that example, but overall, well, I would say these are some of the more difficult problems you'll see in this module, just because they're so lengthy, and there's a lot of places you can go wrong with expanding and forgetting to distribute a minus sign. But when you have these polynomials with the difference quotients, essentially everybody left over should have an h in them in the second to last step, so you can factor that out. So are there any questions on any of those steps? So let's move on to the next one. Okay, find the slope through the 2 points. Pretty easy here, just slope formula. So number 19, slope between 3, 4 and 4, 6. Remember the slope formula is y2 minus y1, so 6 minus 4, over the first coordinates, 4 minus 3. So that just comes out to 2 over 1, so the slope is 2. Very straightforward problem. Remember, positive slope is going to be rise from left to right. Negative is fall from left to right. 0 is horizontal, and undefined is vertical. So we went over that last week. Another problem here. Again, we'll just very straightforward find the slope. And another one, find the slope. So those are all very similar. We'll skip over those. I don't think you'll have any problems there. Okay, what is the point slope formula of the equation of the line? So that's the two main formulas of the line for us. We have slope-intercept. Right, this form is y equals mx plus b. Now you can get away with just using this form unless they specifically ask for point slope form. So point slope is the secondary form. So that's y minus, I don't know which form you like, if you like to use subscripts or not. When I first learned, they would use h and k for the point on the line, but I think nowadays they like to use y0 and x0. So y minus y0 equals m times x minus x0. So here, m is still the slope, but now x0 comma y0 is any point on the line. So in this one we have slope equals 2 and passes through uh, 6 comma 3. So we have y minus 3 equals 2 times the quantity x minus 6. So that would be the point slope form right there. You literally just look at what they have, you plug it in, that's it. If they gave you 2 points, you could first find the slope using the slope formula, and then you could pick either of the 2 points. It wouldn't matter which one. So that's one of the reasons that I kind of like slope-intercept form better. Slope-intercept, you can recognize if 2 lines are the same, right? They have to have the same slope-intercept form equation. Whereas point-slope, there's lots of different points you can pick. So when you're just looking at the point-slope form, you could have 2 equations that look different but really represent the same line because you've just picked 2 different points. You would have to put them into slope-intercept form to tell if in fact they're the same line, or they could possibly be parallel if they're not. So the point-slope form here, I think we just type in what we have, y minus 3 equals the 2 times the quantity x minus 6. And then the slope-intercept form, that's really easy to go to slope-intercept once you have point-slope. You just solve for y. So expand and solve for y. So we would say, okay, well, y minus 3 is 2x minus 12. And then we just add 3 to both sides. So we have y equals 2x minus 9. So y equals 2x minus 9. And that's it. Okay, so this is going to be pretty similar. I'll go ahead and do this one, though, because we have lots of negatives, and it's good to understand how those work, or at least look at one so we're not making mistakes with negatives that can make everything go completely wrong. So for number 23 here, we have slope of minus 3, and we pass through negative 6, negative 3. Somehow my mouse froze on me here, so that's not good. Well, it's not good. Fortunately, everything's frozen. All right, so technical difficulties for a moment, but we're back. So we're just trying to do the point slope and the slope intercept for line with slope of negative 3 and the passing through the point minus 5, minus 7. So as said, this should just be y minus negative 7 equals the slope, negative 3 times x minus negative 5. So we get y plus 7 equals negative 3 times x plus 5 here. So that is the first part, y plus 7 equals negative 3 times x plus 5. So I wonder if they want us to do minus negative the same way we did. Oh, they changed the numbers from when I came back from before. So that's the issue. So before the recording went away and we had to start over, they changed all these numbers. So the new numbers are slope of negative 8, passing through minus 5, minus 7. And so that's going to be, again, y minus negative 7 is this negative 8 times x minus negative 5. So we have y plus 7 equals negative 8 times x plus 5. So the only thing that changed was the slope in front. Okay, now the slope intercept form, again, just multiply the negative 8 through and then subtract 7. And we're going to be all done. So we get minus 8x minus 40, and then we subtract 7. So we get y equals minus 8x minus 47. That should be the answer. Right. Again, graphing the equation of a linear function is really easy. It's just a two-step process. So You identify first the y-intercept, which is the constant term. In this case, with this example, it's -8. So we first find that point, -8, which is down here on the y-axis. It's just first asking for us to identify the slope, which is the number next to the x, 4/5. And then the y-intercept, which is the other number, -8. Pretty easy. And then from there, they want us to graph it. So the fastest way to graph this is to first find the -8 along the... So click the line tool first. And then it's a two-step process. You find the point on the y-intercept, which is -8. And then you go from this point, this -8 on the y-axis, you can find a second point by using the slope. So remember, positive numbers are oriented upward in the y direction and right in the x direction, and negative numbers would be downward in the y direction and left in the x direction, the horizontal direction. So since our slope is 4/5, that means if we go up 4 and then to the right 5, we'll find another point on the line. So from here, count up 4, 1, 2, 3, 4, and then right 5, 1, 2, 3, 4, 5, and then that's the second point on the line. And 2 points is enough to draw any line, right? 2 points uniquely defines a line. So we can check that and see that that is the answer. So that's the easiest way to find the equation of the line. You could plug in a bunch of different x values and then find the y values, but you only need 2, so that's the easiest way to do it in my mind. Again, now if you have x equals a number or y equals a number, you get into horizontal and vertical lines. We already talked about that last time when we looked at the 4 possible graphs based on the value of the slope. So positive being upward from left to right, negative being downward from left to right, and then vertical being undefined slope and horizontal being a slope of 0. So if you have x equals -4, these are just all the points on the graph that have an x-coordinate of -4. And the x-coordinate of -4 represents a vertical strip. So if you want to graph that, you can just pick any 2 points on this vertical line that have x-coordinates of -4. Right? An x-coordinate of -4 would be any point on that strip. So similarly, if you saw y equals a number, that would represent a horizontal line, which I imagine we'll see. Well, maybe not. Okay, this problem right here, number 26, we see the so-called standard form, which is not really so useful for anything other than maybe finding some intercepts. But I believe they're just going to ask us some questions about it, and often for answering those questions, one of the easiest ways is to just rewrite the equation in slope-intercept form. So that's the first thing, part A, rewrite in slope-intercept form. Anytime it says rewrite in slope-intercept form, that's all you have to do is expand and then solve for y. This is already expanded, so that's all you have to do is subtract 4x and subtract 1. Do that on both sides, and we have the equation in slope-intercept form. So we have y equals -4x minus 1. And again, the slope is just identified there, the number next to the x, the -4. The y-intercept is the constant value of -1. And then graphing it is going to work the same way, right? First, we want to identify the y-intercept. So click the line tool, identify the y-intercept of -1. And then if we have, so the y-intercept here is -1, and then the slope, again, to think of that as an instruction set, we want to think of that actually as a fraction. So any fraction you can put over the number 1. So if we think of it as -4 divided by 1, that would say go down 4 units and then to the right 1 unit. So that will give us our second point. We go from here, count down 1, 2, 3, 4, and then count to the right 1. And then that gives us our graph of the line that we were looking for. Okay, so we have another similar problem here. This one solving for y is a little bit trickier, so we'll go through this as well. It involves an extra step of dividing. So for number 27 here, we have 5x plus 6y minus 30 equals 0. So we want to solve for y here. That's going to require two steps. So the first step is to isolate the y term, which is 6 times y. So we're going to want to subtract 5x and then add 30. So we have 6y equals minus 5x plus 30. And then to isolate y, we're going to divide on both sides by 6. So we have y on the left-hand side, but on the right-hand side you have like one big complex fraction. So remember that you can separate those into two terms by using the common denominator, right? You don't have to put things together with a common denominator. You can also split them apart. So really this is the same as minus 5 over 6 times x plus 30 over 6. And in simplified form, that is y equals minus 5 over 6x plus 5. So we see that we have a y-intercept of 5 here and a slope of minus 5 over 6. So we have our slope-intercept form. And so our slope, again, is just the number in front of x, minus 5 over 6. And the y-intercept is the constant term of 5. And then to graph it, we're going to do the same thing that we've been doing. First, identify the y-intercept. So click the line tool, identify the y-intercept of 5. And then from here, the instruction set is minus 5 over 6. That means we want to count down 5 and to the right 6 from the y-intercept. That'll give us a second point. So down 5 puts us right on the x-axis, and then right 6 puts us here. So actually, with this example, we've really just graphed both of the intercepts, the y-intercept of 5 and the x-intercept of 6. Again, notice that the slope is negative and our line is going downward from left to right, which is what we would expect. Okay. Number 28 wants us to use the intercepts to find the graph. So remember how to find the intercepts. So let's do it in two parts. So to find the x-intercept, set y equal to 0 and solve. And analogously, to find the y-intercept, set x equal to 0 and solve. Right, that makes sense because all points on the x-axis have a y-coordinate of 0, and all points on the y-axis have an x-coordinate of 0. So for this problem, 9x minus 4y minus 36 equals 0. We can first look at our x-intercept. So we set y equal to 0. We would just be left with 9x minus 36 equals 0. You can add 36 to both sides, so 9x will be 36. And then divide by 9, we get x equals 4. So we have an x-intercept of 4. And then the y-intercept, we would just set the x equal to 0. So we'd have minus 4y minus 36 equals 0. Add 36 to both sides. So minus 4y equals 36. Then we divide by minus 4. And we get y equals minus 9. So x equals 4 and y equals minus 9. Those are the two intercepts. And then that's another way to graph a line, identify the intercepts. And that should give you enough information. There is one case in which you won't be able to use the intercepts to graph the line? Well, there's a couple of cases, right? Can anyone think of any ways in which the intercepts wouldn't give you enough info to graph the line? Okay, well, one is, what if the x-intercept and the y-intercept are the same thing? Then that would only be 1 point, right? Because it would go right through the origin, 0, 0. So if it goes through 0, 0, you only have 1 point. The x-intercept and the y-intercept are the same, and then you wouldn't have enough info, because to graph a function, you actually need to have 2 intercepts. Okay, so that's one. Another one would be, is what if it's either parallel to the x-axis or parallel to the y-axis? Well, that would be a horizontal line or a vertical line. Okay, so in those cases, you would not have 2 different intercepts. But we know how to handle those cases. We can use just the intercept and then the slope to find another point, the way we have with the other graphs. Or vertical or horizontal lines, we know how to graph those. Okay, so then we get into parallel and perpendicular slopes. So number 29 here. So the thing to know here is if 2 lines are parallel, the value of their slopes is identical. Right, so they're going to have the same slope if they're parallel. So in this problem, we want to find the equation that of the line that passes through -5, -7, and parallel to y equals -2x plus 5. Well, if it's parallel to the line, that's all we care about is the slope. So this is the same problem as the line passing through -7 and having slope of -2. That's all we care about from knowing it's parallel to that line, is we know the value of its slope. So we could do this either way. We could use point slope, or we could use just slope-intercept. Let's go ahead and use point slope, since that's what we've been doing today. So we would have y minus the y coordinate. So y minus -7 is y plus 7. And that will equal our slope, -2 times x minus -5, which is x plus 5. So that is the point slope form. Y plus 7 equals -2 times x plus 5. And then slope-intercept form, again, we're just solving for y. So we have y plus 7 equals -2x minus 10. Subtract 7 on both sides to isolate y. And we have y equals -2x minus 17. Any questions there? Okay, so on the home stretch here. Number 30 is about perpendicular lines. So if 2 lines are perpendicular, so what does perpendicular even mean? Yeah, exactly right. They intersect at a 90-degree angle. Thank you. Intersect at a 90-degree angle, or a right angle. The slopes of their lines Okay, so what is the relationship between the slopes of the lines? Anybody know? So they're reciprocals, but one other thing? opposite signs. So they're opposite reciprocals is what they say. So they'll have, if one is positive, the other will be negative, and then you'll also flip it over, take the reciprocal as a fraction. So I'll say the slopes of their line are opposite reciprocals. So let's say, for example, if one line has slope let's say equal to 2/7, any perpendicular line must have slope equal to -7/2. So you have to flip it and you have to change the sign. So for this problem number here, we're passing through 4, -4, and perpendicular to y equals 1/4 x plus 5. Okay, so what we really want to think about is, what is the slope of our line? Well, the slope of this line that we're staring at is 1/4. So the slope of the perpendicular line, which is what we're trying to find, should be -4/1, which is -4. So -4/1, the opposite reciprocal, which we will just write as -4. So we can now use the point slope form. Y minus the y coordinate. The y coordinate's -4, so that's going to be y plus 4 is equal to the slope, -4 times x minus 4. See, it's always kind of bad when they use like you have a new concept and then they have an example with all the same numbers, because it kind of makes it hard for students to place what is going where. Right? We have 4 for every single number, so it can be confusing to identify the x coordinate from the y coordinate from the slope. Anyhow, let's go ahead and write this in. Y plus 4 equals -4 times x minus 4. And then we'll want to solve for y again. So, whoops. So we have y plus 4 equals -4x plus 16. And then we want to subtract 4. So we have y equals -4x plus 12. That's it. Okay, so the last few. So number 31 here. We're not going to do the whole problem, but I'll show you how to get started. So we have passing through -7, 5 and parallel to 9x minus 2y minus 7 equals 0. Well, this is going to work just like the other parallel problem. The only thing here is we don't know the slope just from looking at the equation. So first we just want to put the equation in slope-intercept form, and then we'll know the slope. So if we have 9x minus 2y minus 7 equals 0, again that's 2 steps. We subtract 9x and add 7 to get the y part by itself. So we have -2y equals -9x plus 7, and then we need to divide by -2. So we'd be left with y equals, and then split each part up over the common denominator. the first part, the slope, will be minus 9 over minus 2, which is positive 9 over 2. The two negatives will cancel. So 9 over 2x, and then plus 7 over negative 2 is the same thing as minus 7 over 2. Okay, so when you're working on this problem now, this problem reduces to passing through the point negative 7 comma 5 with slope 9 over 2. Okay, so you have to do that first step in order to apply everything else. And then from there you can just use point slope form, right? Y minus 5 equals 9 over 2 times x plus 7. And that's how you would finish the problem. And then you would do the same thing here for number 32. You would want to solve for y to find the slope, but then rather than the slope being the same thing, you need to take the opposite reciprocal because it is a perpendicular slope. So one additional step, but nothing different. Okay, so then the average rate of change for the last couple. So the average rate of change. So the average rate of change is just given by the formula f of b minus f of a divided by b minus a. So in this function, let's say f of x equals 3x from x equals 0 to x equals 9. It's going to work just like slope. We just have to plug the values in to find the y points first, the y values. So we first do f of 9. I like to do the larger one first. Plug 9 into the formula. That's 3 times 9, which is 27. So this gives us the point 9 comma 27. We plugged in 9 for x and we got 27 for y. And then f of 0 is 3 times 0, which is 0. So we plugged in 0 for x and got 0 for y. And then to find the average rate of change, we just use the slope formula from here. So the average rate of change really isn't that different from the slope. We just have to get the y values first. And this is technically the slope of the secant line that connects those 2 points on the function. The function itself may not be a line, but you're just approximating the slope of the line, or finding the slope of the line that goes through those 2 points. So we would have 27 minus 0, y2 minus y1, divided by 9 minus 0, which is 27 over 9, which comes out to 3. So the average rate of change here is 3. And then the last one, we have another average rate of change. Number 33 just so happened to be a linear function already. So the average rate of change was just the slope. For number 34, however, we have something a little more complicated. So we have, we want to find the ARC of f of x equals x squared plus 6x from x equals 2 to x equals 7. Same steps as the last one. So we plug in 7 first. F of 7 would be 7 squared plus 6 times 7. So that should be 91. And then f of 2 would be 2 squared plus 6 times 2, which should be 16. So again, this is the ordered pair 7 comma 91, and this is the ordered pair 2 comma 16. And then we just do the slope formula. So the average rate of change here is 91 minus 16 divided by 7 minus 2. So this is going to be 75 over 5, which comes out to 15. Okay, so that's it. That's the last one for this section. Does anyone want to look at any of those problems again? Okay. We'll stop here.